Hello everyone, it's me, Professor Aaron Albert, here again with Lesson 13. Let's learn some econ. So today's goal is to continue our discussion of CV and EV, particularly trying to solve using Cobbs-Douglas utility functions. So you might remember from before that CV and EV are measuring largely the same thing, namely how many dollars better or worse off we are after some sort of price change has occurred. To find CV, what you want to do is find the dollars you'd need to get the original utility level after a price has changed. So we'll find the original indifference curve associated with our original max utility, find how to get that number of utils at the new budget, and the difference in the dollars is CV. For EV, you're going to find the new max utility after a price has changed, find out how cheaply you could reach that utility at the original prices, and the difference between those two numbers is going to be your EV. So let's try to do a real one. First, let's set it up. What do we need to do to find CV? Write it down in your notes. All right, so the first thing we need to do is find max U original prices. Then we're going to need to do min, I'm going to call that U star, min expenditure subject to that U star. Then 3, we're going to call it E star. And then we just need to find the difference between Y and E star. Yeah, just like it says. So first thing we need to do is find our original maximum utility. Ask yourself, how can we do that? Hopefully the answer you've noted is, well, I've got Cobbs-Douglas utility. That's one of our usual suspects. Pretty easy to solve that if we Lagrange it out. So you'll note that we have L equals U plus gamma 10 minus 2P1 minus P2. Find your FOCs. Then, if you work your FOCs, you can get MRS equals MRT, plug that into budget, get Q1, Q2, and then get, we'll call U star. Now, going through all of this would take us a ton of time, so instead I'm just going to invoke a little shortcut. If you look in the last chapter of your textbook, there's little cheater functions that tell you actually the solutions for some of the usual suspects. For instance, the Cobbs-Douglas utility function is always solved by Q1 equals the coefficient associated with Q1, i.e. 0.6, times Y over P. Q2, similarly, is going to be the coefficient associated with Q2 in your utility function times Y over P2. With that in mind, what's Q1 and Q2? Well, Q1 is just going to be 0.6 times 10 divided by 1. So 0.6 times 10 is 6, divided by 2, 3. Q2 is going to be 0.4 times 10, that's 4, divided by 1 equals 4. That means our original max utility is just going to be 3 to the 0.6, 4 to the 0.4. So step 1, done. We cheated a little bit, but still, we finished it. Okay, next thing we need to do is find some magical Q1 and Q2 that reach this U star at the original prices. How can I do that? Well, again, we have a Lagrange function. We want to minimize our expenditure, and we want to do it at the new prices. So we need to look at P2 is 2, so 2Q2 plus 2Q1 plus, our constraint is that U equals 3.6, 4 to the 0.4. And again, that'll suggest FOCs. Those FOCs will give us MRS equals MRT. Plug those into budget. Get Q1 prime, Q2 prime. So when you do this, you will note that the first two FOCs are just going to set MRS equals MRT, And this will be the same MRS equals MRT you would have gotten when we solved for our original max util, namely the price ratio equals 3Q1 divided by 2Q2. And you'll note the price ratio is 2 to 2 or 1 to 1. So with this in mind, can we solve for Q2? Well, 1 equals 3Q1 over 2Q2. So it should be the case that Q1 equals 2/3 of Q2. So what can I do with this Q1 equals 2/3 of Q2 function in order to get numbers for Q1 and Q2? Well, we still haven't used our constraint. Take this Q1 equals 2/3 Q2 and plug that in to our U equals 3 to the 0.64 to the 0.4. You'll find this. This is an equation with only one unknown. This can be solved for a number. I'm not going to do it because it would be messy and have a lot of decimals, but this is totally solvable. So we're number 10, we've solved for this. We're just going to call that Q2 prime. Similarly, we could take Q2 prime, plug it into this, and get Q1 prime. Again, we have two equations, only one unknown. We're good to go. Note, if we have numbers, they'll be messy, but they're still numbers, for Q2 prime and Q1 prime, how can I find my total expenditure, i.e. my E prime? Well, just take Q2 prime and Q1 prime, multiply them by their prices, and add them together. That'll give you E prime. Our E prime will just be 2Q1 prime plus 2Q2 prime. With this, how can I find my CV? Well, you'll remember your CV is just the difference between how much you have to spend at the new prices and how much it costs you at the old prices to get the same util. How much did it cost us at the original util to get... how much did it cost us at the new prices to get the new util? Well, we found that max util using $10. So it's just $10. So we know the difference between $10 and this new E prime must be our CV. And that's all there is to it. The best way to learn this is through repeated practice. So go through the same exact exercise and find yourself EV for the same functions and the same price change. Good luck. Let me know how it goes.